And here we start to see, right? If we want to access what modal, we already start to see some variables here. So the capacitor at this moment, it is being established that all my descriptions are here as well. So it will now reach the first stage projector and reach 0020. Here absolute. So, for example, here in the condensation system, there are some variables here, which will require the operator to perform some maneuvers. So, for example, we will start to have a loss of boat. There will be a situation of, will require the operator to perform some maneuvers here, such as the hot well. Then it will start to increase the level of condensate there. So there are some variables. It will have to start losing efficiency in water heat exchange. Okay. So we get this here. Everything is impacting. He will lose, for example, the vacuum that he will establish, there will be one. Then he will understand here. The one who will have to do a maneuver to change the heat exchanger, right? The heat exchange is not good. The filter when it is saturated. So there are some maneuvers here, otherwise he will. If he does nothing, do not intervene in the respective alarms. Here the turbine machine can be directed to the tripod. And that's it. Why are we going to monitor? So here the load curve will show us where we are operating in this situation. Now, that we did, if you notice, we are working with close to 15 mega. Here, it is showing the steam flow and we are not walking in normal operation itself, exactly on top of the line. So we will begin to understand why. So, if we start looking at the boat, for example, we will see that we are not in the most comfortable situation to work. So, hello, welcome to Turbivap. Another video. Here we talk a little about steam turbines and how it could not be any different. Today I wanted to show you a little more detail about our web-based simulator for thermoelectric plants. Actually a simulator, aimed at an educational simulator for the steam turbine part, involving the main subsystems of a turbo generator. So for that, I recorded this video here too. Shows a little more detail than the one we spent, but above. Some things we are implementing, some updates. Show you now some features. And leave it here in contact for anyone who wants to know more about it. For individuals or legal entities, companies to assist training of these professionals who work with this equipment. A fully controlled environment here to be able to carry out training. For those who don't know yet, this simulator was developed here by it is available in a web environment within our training platform. There are also in-person steam terminal training courses. In the company of, we go to all the closed companies to apply our course. We also have the digital remote format. Then we have greater interaction and ease of application, of making this course viable, and also the digital format. Recorded in video class. So, depending on the type of course, we also have integration here with our platform, where we can customize some other additional modes, including access for the team and the simulator. So, as I said, it stays here within our platform. Take a look here for more details on how it works in this environment. So a buggy area is here our course. Here we have a presentation of video classes. Here we can configure the modules according to the profile of each person, each prisoner, each user. It's okay? So, going into detail about our voice actor. So I'm going to open it here so we can go into a little more detail. He will carry it here for us, and then go over some features and obviously, make a summarized version. If you are interested, we can give you more details in a demonstration to understand a little better about this simulator. Just get in touch with our support. Here in the description you will find all the details, because the simulation depends on the type of course we will see here. As to break this machine, it will have its own dynamics, it may take a little longer. The full cycle of the main features, some tools, alarms, alerts, anyway, it will depend on each client, each simulation we do, so obviously this presentation will be very short. Anyway, this is our initial appearance here of our software, of our savior. And here it will give an overview on the welcome screen here, showing the main features of our simulator. Is it okay for him? Go as if it were a basic lesson here, showing those who are arriving there for the first time the operating dynamics of our simulator. Okay, so if you want to come back here, it's very briefly. Here we have it in the version that we are still in the beta version. We are making improvements, making some updates here. He will make an operational adjustment, so here we will be able to start to rotate the tripod, as well as restart the simulation. The turbine starting temperature can also be adjusted here before starting. The hotter, the faster the simulation. However, skipping some phases, so as if it were there in practice. How we are going to start our simulator here. The only input we need to provide is to adjust the temperature of the water, the system, the housing, the turbine intake block. Well, then we select there from that, and that adjustment triggers the sequence of operations. It's okay? Then, when the turbine is operating, we can use our slide from here to define the amount of generation, the megawatts here that we want to generate. Then we will be able to observe that the intake valves open in sequence. Must exit the charging tube outlet and all other characteristic details. Here, he'll draw attention to our panel. Here are the main gauges. Keep an eye on them. Here we have the operating profile. He will be introduced to us here. The entire performance graph, the historical evolution. Here is a function of time here. The auxiliary systems, agent working, we no longer look here in new modes. So this is basically this information, right? So let's start here. Obviously I'm going to leave. I'm going to consider a simulation here. I will consider splitting the carcass cold to give us more details here. Then I'll pause here and move forward to bring it here, doing the most important movements here for our simulator. It's okay, so let's start here from the cold machine and let's consider that here we can adjust to. I don't consider that I'm starting the machine here, the turbine at 30 degrees. I'm going to give a start command here. Here it will give a status starting from carcass heating. It will give you the estimated time here. In the case that it is giving 22 minutes in that time, he will adjust and here he will give us some guidance. He gave the first one there and already recorded it here in the event log. Then simulator started to begin the starting sequence. So when did he read it? From the start it will be cold, because the temperature is as if it were. Experimentation on the carcass, he's already halfway there and is starting the match. Cold, then it is necessary to heat the carcass to 80 degrees. In this case here in this simulation, the temperature is below, it will also turn on the heater there. Here he has already turned off the oil heater, deducing already here that the temperature reaches all the logs that are recorded here. If we click here, we will have more information. Then he gives the main function of each one, the reference values operation. We are thinking about adding video lessons here as well. So those classes that we have already recorded, that we already have and created within. From our digital environment here we are the ones who address this subject, mainly. After asking the subject in question here, we will also put a video here. Class for anyone interested in getting a better understanding of the subject. So now he will register here at the next event, and wait for it to reach 80 degrees in the housing. So here is increasing the temperature, it will be at 60. And then we monitor a little bit of that. Here is some information, it's all in here. Well, it's well explained here. We'll have the find tab here. That ends here. Let's take a look at other features here. So here we have here bearing monitor. So we will be able to observe all types here. Temperature graph, the evolution is, then the vibration orbitals. We click here and see the vibration peaks and everything else. Here it goes. His dynamics are here. We have a little diagram here showing the main points in there of the machine. How are the conditions at those points? Obviously in this case we are heating up there. The resistance of the carcass still, so the data here is not being updated yet. Here on our platform we have already shown it here too. Eventually we already have an assistant for the students here. So, regarding the subject of principles, in fact, we still want to remember here some theme or some subject well, in a very dynamic way. And very fast, so it's already integrated with our assistant. So, for example, why should get hot in the oil when starting the turbine? Then he will give us his insights about himself, right? For each log inspected here and our assistant already knows in what stage are we at here. Simulator and respond based on this more accurate information. Okay, so here coming back here, it has already reached the temperature of the carcass. The auxiliary oil pump has already started. The oil pressure is now okay. The auxiliary steam system, the sealing pressure, has already been established in vacuum, so it is starting injector starting. So here we already have it here. The vacuum in the condenser is already starting to be generated. And here we start to see, right? We want to access here. They have changed. We are already starting to see some variables here. So the condenser vacuum is now being established inside here. All descriptives too. So he's going to reach it now, right? First stage projector reach 0020 goes here absolute, right? To turn it off, the others are there. Turned it off. Now I've turned on the second stage. So here it is, creating a vacuum so we can know what's going on. Then it goes up to 0.08 bars, so the allowable vacuum has already been reached. So now it will start to accelerate the turbine up to 100 revolutions. Then from here on the starting curve he will start to accelerate. Turbine we can see all the indicators here, of what is happening. But it's not, obviously, because it's a simulator, it's not static. So, for example, here in the condensation system, there are some variables here, which will require the operator to perform some maneuvers. So, for example, we're going to start having a boat pile. There will be a situation where he will demand from the operator that he does some maneuvers here, like a hot well. So great, the condensate level will start to increase, so there are some variables. It will have to start losing efficiency in water heat exchange. Okay, so we can do it. He needs it here. Everything is impacting. He will lose, for example, the vacuum that is established will have a boat loss. So the operator will be forced to understand directly and indirectly there the actions he takes and the behavior that the respective actions have. Then he will see what caused it. The worsening of the vacuum. What improves? What is the result of all this? So, for the lubrication system too, right? Then he will understand here. The one who will have to do a maneuver to change the heat exchanger, right? The heat exchange is not good when the filter is saturated. So there are some maneuvers here? No, he will. If he does nothing, do not intervene in the respective alarms. Here the turbine machine can be directed to the tripod. And that's it, why we're going to monitor. So here now we have the rotation here on the graph. So he's telling us he's going to wait to complete the slow spin. There is no one so unexpected that 7 minutes. Then we will see the next steps. So what's going on here? We've had some alarms before. It was paused, but it's here. He warned us here that the oil tank level is low. So here the modal, respectively, will enter here. He's already going here. Which are the limits? What are the alarms and trips in these conditions? So we will always have to intervene here. In this case, I'm going to complete the level there, okay. So that's it. This is one variable, but there are countless others out there. That we can understand the behavior back then here. He already made the first ramp here. He's already giving another example. Sufficient rotation, disabling the lift pump. So he's going to show what happened, okay. So, here he indicates, we have already started to admit parts of the vapor, then. So the valve here, every time it blinks, right? What does modulating right? Is an electronic signal that already is being sent by the regulator there to the control valves. She is doing the opening. Valve 1 is 53% open, so we're starting to actually admit steam here. We'll take a look here, then change the lubrication system that is happening. So this filter here, it has already reached saturation, so he says that if we don't clean it, I'll change it. In fact, if we don't replace it, what will happen is that the machine will disarm. Or it will alarm first due to the increase in oil temperature. So we're going to do the maneuver here, then the oil filter will be changed to another unit. The point that was in use can now be cleaned or replaced. And there, shall we continue our game there? Let's wait for the next events there, some updates here. So he's still accelerating. First 1850 revolutions per minute. Here we left the unit. We were on our ramp. The slow spin we are accelerating here. It made an upward leap here on the chart. There is no vertical ramp here in acceleration. And then he says, why does he then speak to me here? He passed through a critical zone, is not observing this, but it will be reflected there in the places. So, if we analyze here, the vibration was also felt there, here. Such was the behavior of the bearings. The temperature here in the other modes didn't change much. Generator is not yet analyzing any metrics, because we are warming up here. Tank level again, I need to warm up here. It is showing that the oil is also passing, modulating the temperature valve in our vacuum system. So if you notice here, we're starting to have that analyze here only the vacuum in the condenser. The vacuum is now in this situation. Here it is 0.09, but then we start to have it here. A warning here, the normal reference is 1.5 times, this is indicated. A considerable filtration, and above that here it will have to be investigated, then he will start to interfere. If you look out at sea, then we'll have it here. Eventually, he's sending people into the field there to see why. Here too, in this case, I have to adjust it again here. I'll wait a little longer there. Or now we are here close to the nominal rotation for the generator. Take action. So for us to synchronize the generator tube there with the station. So here now it shows the machine has been synced. They're saying to close. Now we start loading the information in the electro system itself. And also the cargo load starts to appear here for us. Now the turbine actually starts to operate. So let's, for example, increase our load to 14.5 megawatts. Now events begin to happen more intensely. So as we increase our generation, there is the vacuum system, it will respond faster. Our variables also follow the entire process. Then we start to have a more interesting dynamic. So, here, the load cross will show us where we are operating in this situation. Now, with what we did, if you notice, agent is working with close to 15 mega here. It is showing the steam flow. And we are not moving forward with normal operations, exactly on top of the line. Then we will begin to understand why. So, if we start looking through a vacuum, for example, we will see that we are not in the most comfortable situation to work. So, why will we be able to, for example, adjust the inlet temperature of the cooling water set point? And then we begin to understand what is happening. And then the dynamics start, as I said, to be different. So we've already had a double alarm here in the water, which was low level from the manufacturer. So let's complete the level. Here we already have 2 other alarms that we couldn't show you before. We don't change it here. The heat exchanger, we will start to see heating in the bearings, in the oil, then it will be eligible for credit as well. So let's now look at the load curve, or how he already walked up the line. We were out of range here. Now we are sailing on the line. Now you will see its condition with extraction enabled. So here, notice, we have nothing in extraction. So let's enable extraction here. It's extracting a base there. It is only demonstrated that now our extraction will be a yellow line and then we will increase it. So from here we increase to 10 bars. So it's saying here that it's quite limited to maintain the minimum flow to the exhaust. So automatically we will see a momentary drop in generation until it is corrected. If we analyze now what is happening, our load curve, we are already sailing up there, in line with an extraction. So, to make the same as the previous generation, we are using more steam. It's so in this tool that can clearly show all these direct and indirect relationships, what each parameter changes in the machine's performance. Okay, here we go again. We're going to have some history. So, for example, what we delete here, let's analyze the spectrum left over unmarked turbine axials, for example. So we will observe here, there is also a difference in behavior between the active bearing and the inactive one, you know, and it's always more in demand. So he will have a behavior. From the moment we increase the loads on the machine, we start to have a higher temperature on it too, so it's quite realistic. It's not quite like that. The real side of field practice in a thermoelectric plant, where the last generator of the generator. That's what we're offering to companies. And for people who really want to delve deeper, then we include steam. Here we can, since the condition is, at this moment here at the generator. How is the generation, the scalability, the other parameters of active reactive power, the grid frequency as well. Let's comment a little more here. It's about playing at the maximum of the generation that we're talking about here, which, in this case, that generation is being limited by the low efficiency of the vacuum. Okay, so he gives us a message here that the maker's boat is not aware of the boat. This increases the pressure. So I mean, this. We will have to act here and adjust all these variables here, so we can get the specific direction of the turbine. Okay, who's giving the steam condition? How much steam, pressure, flow, temperature is entering? When we are extracting, where is our career curve? Where are we at this moment? Then disable extraction here. It will represent it on the graph for us. You can see here, in this case, we're doubling now. It has all the new 100%. It is also at full charge. And so we make all the adjustments. So, for example, if he enables us here a demand, a generation and not correct the respective parameter. For example, if the boat is not in good condition, we will start to have problems. So, just like with oil, we increase the machine's rotation, do not have the oil at the correct temperature. This will also be reflected in machine monitoring. You will start to detect the hot wall level here. So what's going on? Our hot is very high. He now started to spin more. Okay then, so the intensity of the operation is increasing. So we have to come here too and turn on the condenser pump. Then a thermoelectric plant, this automated metal thing, right? But here we are to understand the dynamics, so we have the capacity. With just one pump, 2 pumps for us to do these maneuvers. If not, it will also cause problems. We will have a drop in performance, a movement of the rotor, up to a pipe, eventually. So that's it. There are many other features in here. We intend to include other modes soon. So, for anyone who wants to be interested in the subject, get in touch with us here. In the demonstration, we will be happy to show you, okay? Here he is already carrying out normal operations. So the point we are generating there, close to 50 mega, is not delivering everything yet. Why? Because these are small adjustments that we will have to make. And that's where it's interesting for the operator to start handling the parameters, the adjustments, the set point to understand the correlations between the factors. Cool, guys. So that's it. I hope you enjoyed it. Leave your comments below with any questions. If you want to know a little more, contact us. A hug and see you in the next video. Hi.